For decades, one single programming paradigm has completely dominated the way we build software. It's what they teach in every university, it's the go-to for the enterprise, it's pretty much the bedrock of our careers. But what if that entire foundation is cracked? What if the very tools we've been using to manage complexity are secretly the biggest source of it? We're talking about a hidden tax on every single project, a cost so massive it's measured in bugs, rewrites, endless maintenance, and just sheer developer burnout. A cost that might be baked right into the DNA of object-oriented programming itself. So this story starts, like a lot of programming stories do, with just pure frustration. Joe Armstrong, the guy who created Erlang, was talking about a day where he was just trying to get some work done. He updated his presentation software and bam, it starts losing his images. So he tries to switch to another program, but of course, the versions on his two machines were incompatible. He finally gives up and decides to build his slides in HTML, but that needs a tool called Grunt, which he just couldn't get to work. It's that familiar spiral of software just falling apart. And it led him to ask a much, much bigger question. And that question led to this stunning paradox. Back in 1985, a PC had a tiny, tiny fraction of the power we have now. I mean, my laptop has 32,000 times more memory and is over 1,000 times faster. And yet, that old 1985 machine booted in about 60 seconds. Today, my ridiculously powerful machine, it still takes about 60 seconds. Like Armstrong said, something's gone wrong. All those decades of hardware gains have been completely swallowed by our software just becoming a sprawling, complicated mess. So, where does all that mess come from?
The problem is something you can't see. It's called the state space of a program. Basically, the total number of possible configurations your code can get itself into. To try and wrap your head around the scale of this, just look at this number, 10 to the 50th power. That's roughly the estimated number of atoms on Earth, okay? Hold that number in your head.
Now, here's the absolute heart of the problem. This is the part that's just wild. Joe Armstrong calculated that it only takes just six 32-bit variables to hold more possible states than there are atoms on our entire planet. 6 variables. Now stop and think about the applications you work on. We are creating state spaces so astronomically vast, they are fundamentally untested and literally incomprehensible to the human brain. And this isn't a bug. It's a feature of the way we've been taught to build things. All right, so when our programs explode with this much state, we have to ask why. And the answer might just lie in the core principles of object-oriented programming itself. So OOP was supposed to tame complexity, right? But what if its main ideas are actually the problem? Mutable state, where data can just change at any time, anywhere, well, that leads to totally unpredictable side effects. Inheritance hierarchies, they sound good, but they often end up as brittle, tangled messes that are terrifying to change. And this idea that everything is an object, well, it can force us into what one developer called very large belief structures, just needless complexity we bake into our designs from day one. And look, this isn't some new hot take. The pioneers of computing knew this was the whole game, to control complexity. But if you look at the software we have today, it's pretty clear the dominant approach has struggled. As Armstrong put it, we've become the job creators of the future, because we're leaving behind billions of hours of maintenance work just trying to understand code that we ourselves can't figure out a week after we wrote it. So, if the model we all use struggles this much with complexity, what's the alternative? Well, this is where functional programming comes in. And it's not some new trend. It's a completely different way of thinking that was practically born to solve the exact problems the modern web throws at us: concurrency, distribution, and fault tolerance. The mental shift here it's profound. In OOP, you're always thinking about these little objects, these boxes with internal state that is constantly changing. But functional programming flips it on its head. It's all about a flow of immutable data that never changes. You just pipe that data through pure functions, which are these beautiful, predictable things that, given the same input, always give you the same output, with zero side effects. That makes your code predictable, easy to test, and way, way easier to run in parallel. And this isn't just theory. This is real-world stuff. Check this out. When Bleacher Report rewrote parts of their system from Ruby on Rails to Elixir, a functional language, the services that used to need 150 servers now run on just 5, a 97% reduction, and they got better performance. This story just keeps going. At Pinterest, their spam detection system went from almost 1,400 servers down by 95% after they switched some of it to Elixir. Another system went from 30 huge Java instances to just 15. The bottom line, over $2 million saved every single year. And again, performance and reliability actually went up. Choosing the right tool has a massive financial impact.
And these aren't just one-off cases. The world's most demanding systems are running on this paradigm. WhatsApp uses Erlang to handle millions of concurrent connections. Klarna uses it for 100% uptime on its core payment system. Discord built its massive real-time messaging on Elixir. They didn't choose this approach because it was trendy. They chose it because it was the only way they could reliably solve for massive, massive scale.
Okay, so you might be thinking this is just some big pitch for you to drop everything and switch languages. It's not. This isn't about abandoning OOP. It's about something way more fundamental. It's about understanding the true cost of the path that we are already on.
Most of us, we never really consciously chose object-oriented programming. It was just the default, right? It's the water we all swim in. But as the Oracle says in The Matrix, you didn't come here to make the choice. You've already made it. The real goal now is to understand why. And that choice means we accept a world where data can change unpredictably. It means we accept these complex, tangled class hierarchies. It means we accept a paradigm that, for the demands of the modern web, might just be creating way more problems than it actually solves.
So I want you to think about your own work. Seriously, think about the late-night debugging sessions, the fear you feel when you have to refactor some brittle, ancient base class, the cognitive load of trying to hold an entire object graph in your head at once. That is the real cost. That's the daily tax of the paradigm we all take for granted.
And maybe the functional alternative seems so alien or weird only because we haven't really stopped to grapple with the downsides of our default choice. After all, like the Oracle also said, we can never see past the choices we don't understand.
So, for the kinds of systems that we all build today, these distributed, concurrent, fault-tolerant systems that power the entire web, we have to ask the really unsettling question. What if the paradigm we've relied on for decades was simply the wrong choice all along?